Hi, today we're looking at the dot point that we have here on the screen. Justify the hierarchical structural organization of organelles, cells, tissues, organs, systems in multicellular organisms. Now, this seems like a mouthful and it's quite hard to break down, and there's a real pattern to it, and we're going to go through that in today's lesson. So to be able to answer this question, first of all, we're looking at the term justify. Now, it's one of our higher order verbs, so we're breaking down the question. So it's really important here that we plan justify, and we're talking about the organization within our multicellular organisms. So one of the first things we really need to do when looking at this is break the question down, and let's have a look at what those definitions of these structural hierarchical structures are. We need to think about, well, why do multicellular organisms actually have these structures in place? And we're reflecting back on the limitation of size in terms of that surface area and volume that we did in Module 1. And then we need to justify that structure. So moving here, just to recap what we've looked at, our cells are the smallest unit of a living organism. Then we have groups of similar cells that come together to form a tissue. For example, epithelial cells. So we might have one epithelial cell. Groups of epithelial cells come together and make epithelial tissue. Now that epithelial tissue lines most of our organs. So when tissues all come together, different tissues come together for a common purpose, they form an organ. For example, our stomach. So the epithelial cells line our stomach, which is an organ. And then those organs all come together again for a certain purpose and come together and form a system. For example, our digestive system. Now, all of our systems then work together to meet the needs of our multicellular organism, which is why we have this structure here. So if we were to think about multicellular organisms versus a single cellular organism, what is it that is the difference there? Now, obviously, a unicellular organism is one cell. Now, those one cells are usually quite small, microscopic, and hard to see. Why can't a single cell organism be as large as a human? Why can't we have a one cell organism as large as a human? So, I want you to consider that question. Surface area and volume was introduced to you in Module 1, where we had a look at the movement of dye into the three different size cubes that we have. So let's have a look at the cubes that we have here on the screen. In the first one here, it's a 1 centimeter cube. So each side will have an area of 1. So my surface area in this case is going to be 6. Yet my volume is going to be 1 times 1 times 1 is going to be 1. So the ratio here is a surface area to volume ratio of 6 to 1. Now in this one here, my surface area, I have an surface area of 4, but there are 6 sides. So that's going to be 24 centimeters squared. My volume is 2 times 2 times 2, which is 8. And my surface area to volume then is 1, oh sorry, I'll do it the other way, 3 to 1. Looking at this one here, my surface area of one side is 9, 9 sixes are 54, and 3 times 3 times 3 is 27. We're down now to a 2 to 1 ratio there. So obviously, the smaller the organism is, the larger their surface area to volume ratio is. Now in this one here, as the objects are getting bigger, their surface area and their volume are both increasing, but their ratio is decreasing. So let's have a look at this example here. So when we're looking at our smaller unicellular organisms, like I alluded to in the last diagram, why can't they be as big as a human? Smaller organisms are able to carry out all those life processes by osmosis and diffusion. They can get the gases that they need into the cell and the waste products out of the cell. If you look at the diagram here on the left, these arrows, both in the left diagram and the right diagram, are both the same size. In the smaller one there, materials are able to move into the center of the cell and out of the cell again. So all of those life's processes, be that photosynthesis, respiration, waste production, can all move into the cell, and those waste products can get out of the cell again. If we look at the picture there on the right, those arrows aren't able to make it to the outside of the cell. So diffusion and osmosis now are unable to meet the needs of the organism there. So if simple diffusion and osmosis was to be relied upon, the materials are unable to move into or out of the cell to meet the needs of those organisms. So if again you think of the needs of the organism, referring back to Mrs. Gren that we would have looked at in year 7 or 8 when we covered cells, that is our respiration, excretion, yes, there's movement, response to stimuli, but in this case, nutrition. So meeting all those needs of that organism. So what needs to happen is in those larger cells, we need to have a larger, if we're going to have a larger organism, then we need to have specialized systems in place. And that's why we have the structures that we do. So back to the question, we're looking at justify. This is in your work booklet. Justify the hierarchical structural organization of organelles, cells, tissues, organs, systems, and organisms in multicellular organisms. So one example of a justify question, when we talk about justifying, what you're being asked to provide an argument to support it. So for example, justify the rule in Australia that students must stay at school until they're 17 years old, or unless they're in a traineeship for 25 hours a week. It's asking you to provide an argument that supports it. It's not asking you to provide an argument against it. So you need to, in this case, you're justifying, you're acting in the position of the affirmative. So when you're doing your answers, again, you need to provide examples to support your answer. So like I said, this is in your book, so I'm going through this quickly. You can read through this one on your own. You can write a justify response in point form. So for example, it might have research shows that students who leave school early will earn less money when they start work. They're more likely to have long periods of unemployment, will be less likely to return to study later in life. The below example there, and have a read through that, does not meet the requirements. Now, there is a way of scaffolding your responses, and if you look on the internet, you might see a lot of response scaffolding using a method called ALARM. So it stands for a learning and responding matrix. The state system are using this a lot in their teaching to help students structure a response. Writing doesn't come naturally for some people, and me included, and certainly having a structured way to respond helps students actually meet the requirements of the question. So the way ALARM works is they're saying we tend to learn in a structured and scaffolded way, and we should put our responses in the same way. So justify is a higher order verb. It's kind of working beyond like that assess, evaluate, justify level. It's up there at that level. So the best way to respond to these type questions is to plan. Taking a couple of minutes, even in an exam situation, to plan a response will give you back positives much more than if you were just to write off the cuff. A couple of minutes will pay you dividends in the future. So we're starting with I. So we're looking there at identify. So we're naming, we're defining. So what are we defining here? We're talking about multicellular organisms, so let's define a multicellular organism. Using definitions from your book, write down a definition for a multicellular organism. So that's our first point. So a multicellular organism is an organism with multiple cells. integrated, working together, go back to your book and get a really good definition there. Now, D. If we are asked in any question to describe, the good practice, and this has come through from multiple HSC results, is identify it, then describe. At least that way you're making sure you're hitting all the outcomes that they're wanting to see. So we've identified what a multicellular organism is. Now we're going to describe its characteristics and its features. So we might start with, there are a diverse range of multicellular organisms ranging from millimeters in length. Can you think of an example? To organisms that are many meters long. Can you think of an example there to support your answer? But what we've noticed, and we looked in the last slide, but as the surface area to volume ratio decreases, which is what's happening as the organisms get larger, osmosis and diffusion are no longer able to meet the needs of the organism. Okay, so E, explain. These questions are asked a lot in school exams, HSC exams. Again, don't just go straight into the cause and the effect. You start with identify, describe it, and now explain it. And if it was an explain question, we would stop at this level. So with explain, usually it is best if you can use some linking words as a result, as a consequence of, or as a consequence this leads to. Using some linking word from what you described, and then now we're doing cause and effect. So for example, you might have something like, as a consequence, as a consequence of increase in size, organisms might or will require specialized structures such as tissues, organs, and organ systems to perform specific roles that work together to ensure the needs of the organism. So we've done our explain, we've done our cause and effect, our making the relationships evident there. Now we're up to this final level. Assess, evaluate. In your case, you're going to justify, so you're supporting the argument. So something along the lines of, without this hierarchical organization, organisms would be limited in size. So what I want you to do is I want you to either go back and watch this again, pause it along the way. I want you to have a go at answering this justification question in your work booklet. Take a photo and I want you to send it to me. Alternatively, write a response on Word and email that to me. Great. I'll talk to you soon. Bye-bye.